In the second half of Unit 8, these kind of go together, not that we're going to keep doing proofs for everything, but there's going to be some parts of proofs and some of the identities that we continue to use. But we're going to put what we've done with proofs together with Unit 6, back when we used our chart and all. These guys, they're coming back to us right here. I'll put a blank copy up on Canvas if you need this again. So what we're going to be starting today is the process of solving trig equations, and this is kind of what we've been building up towards. This is a big concept going forward into calculus, being able to solve these. So today we're going to start with basics. Next week, we'll be doing a little bit more with factoring and solving and using identities in order to help us. We'll end next week with a quiz over it, and then the following week we'll have like a short test on it. So that's kind of the plan going forward for the next like week and a half. This stuff, the homework from this, is technically not due until after the break. Hopefully I'm going to be done in enough time that you can maybe knock it out and not have to do anything over Easter weekend. At least that's the plan. So that'll be up to you. I mean, if you choose not to do it until Monday night at 11, that's up to you as well. But the homework for this will be due 10 a.m. on Tuesday for second period, 7:45 Wednesday for fifth, and 9:10 based off of our bell schedule on Wednesday for sixth. So that's kind of where we're at. But just before I get started on this page, to kind of pull back in what we did in Unit 6, we talked about sine and cosine values using our charts. So I'm just going to give you a random example here. If I said sine of x is equal to 1/2, and let's think in terms of degrees temporarily. What we're technically solving for here is x. X is the angle in terms of whether I tell you radians or degrees. But think about those blank charts that I brought up just a minute ago. Anyone remember where on our blank chart sine is equal to 1/2?
Give me a second to think about it.
I gotta think about that one. Remember that again.
Oh, 30 degrees.
That would be at 30 degrees. Now, you also remember sine was associated with a y value. So thinking about the unit circle in all 4 quadrants, sine's actually going to be equal to 1/2, 2 different places. One was at 30 degrees in the first quadrant. Where else would sine a y value be positive?
150.
Over at 150. Now, for those that are not remembering that, 150 we would get because thinking about our reference angles, if sine was 30 or 1/2 at 30 degrees, we would also say sine is positive here where the reference angle is 30 degrees. So backing up 30 degrees from that 180 is what gives us that 150. That's kind of where we're at getting into this. Our charts will help us with just specific sine, cosine, tangent values because we only talked about those special triangles, the 30, the 45, 60, and so on. But we're going to get started with some of this just with a basic calculator helping us out with some of these things. So keep in mind, though, the reason I brought this back up is to remind you that there's typically more than one answer. Using our calculators, we're only going to get one, but we're going to use what we know of the unit circle and reference angles to help us find the other. So starting with a basic question on 227, again, making sure that you are in degrees, we are going to take a look at question 1. Now, you can use theta, you can use x interchangeably. If we are given that sine of theta is equal to negative 0.82, what we are trying to solve for is theta itself. So in order to get a value for theta, given that we have a calculator, how are we going to type this into our calculator?
Inverse.
Inverse sine, okay? So inverse sine is what gives us an angle. So we're going to type in our calculator the inverse sine of negative 0.82. This is only going to give me one answer out of my calculator. Okay, so my calculator, anyone else's, gives me negative about 55 degrees, if I'm just going to round to the nearest degree. If you didn't get that, you're probably not in the right mode. So double check that. We're in degrees right now. Now, here's where, just like we talked about on the last one that I talked about, where sine was 1/2 at both 30 and 150 degrees, I need to think about where sine, and this is where we're going to back up a step. Before you ever type the inverse in your calculator, here is where I identify the sign, and by that I mean plus or minus, of my value. In this case, sine is a negative value. In which two quadrants would sine be negative?
3 and 4.
3 and 4, because
3
sine
and 4.
is right? Which one of those two quadrants is that negative 55 degrees?
4.
Okay, that's this one right here. That's 4. Okay, because if you're given a negative value, you always go backwards starting from 0. So I can leave that as negative 55 degrees. I can also change that to 305 degrees if I'm more comfortable with a positive, but I don't care in the fourth quadrant. How am I going to use that information to find my second answer for theta?
You just found a reference angle, right?
I use that as my reference angle. Okay, notice
80 plus 55.
the reference angles are not actually negative, so I'm just using that 55, not the negative. So technically, I'm going to take this, which is 180, and I'm going to add 55, because thinking about the rotation, I'm going forward. So what is my other answer for theta for this one?
235.
235. Okay. So now I'm going to say most questions are going to have 2 answers. Most being our keyword. Some, depending on how they solve, and you'll see this today, will have 4 answers or more. Some may only have 1 based off of the reference angles, but those are more special cases. Okay. Any questions or concerns about how we got what we just did, the 2 answers?
No.
Okay. And this is not technically 3 answers. Notice that negative 55 and 305 are alternate versions of the same thing. So that is 1 answer, and then the 235 is the second. So let's try that again, just with 1 step involved. In question 2, before I determine what quadrants I'm looking at, I have to get the trig value by itself. So I have to get the sine, the cosine, the tangent, the cotangent by itself. So in this case, in question 2, I'm going to just use normal solving skills and do what first?
Divide by 5.
Divide by 5.
First. Here is where I pause and say, okay, I've got cotangent is equal to what kind of number? I don't even really care what this number is over here. I just care positive or negative.
Positive.
Positive. All right. So if cotangent is positive, we're a little bit less used to thinking about cotangent, right? How could I change this to make it a little bit more comfortable for myself? We're a little more used to thinking about its reciprocal.
Decimal.
Flip
So
it.
if cotangent is equal to 12 over 5, what is tangent equal to?
5 over 12.
5 over 12. Now, you don't have to do that, but a lot of times we're more used to thinking about the positive and negative quadrants based off of sine, cosine, tangent, rather than the 3 reciprocals. So then my question to myself is, in which of the 4 quadrants is tangent positive?
When the signs are the same. So 1 and 3.
Yep, when sine and cosine are the same, so 1 and 3. So before I ever get started, I already know which 2 quadrants my answers are in. Now, if you have an inspire, you could have the inverse sine, cosine, tangent, and the 3 reciprocals. If you have an 84, you don't have the inverse buttons for the 3 reciprocals, so it's especially important for you to change it into that form there, because now to type this in our calculator and get our first answer, if you have an 84, you have to do inverse tangent of 5 over 12 because you don't have inverse cotangent. If you are an inspire, you have inverse cotangent and you can do either one. But both ways, my first answer should be about 22.62 degrees. So I'm going to round that to about 23 degrees. That is obviously this answer. How am I going to use that information to get my second answer?
Add 180.
Add 180 to that. Use that as a reference angle. Therefore, my second answer is about 203 degrees. Any problems with that? All right, so this is the basics of this, and really like take longer to work on these because they are. Does anyone else see this random red mark in here on my notes?
Yes, I see it.
Yes.
What the world is that? I have no idea. What the heck? Whatever. Anyway, I'm just gonna have to live with that apparently. So for question 3, we're gonna do this one more time with degrees. We'll talk about radians quickly and then go from there to finish up. We will be bringing in the chart a little bit. So if you have a copy of that you want to grab somewhere, we can do that too. So for question 3, we just have a little bit more solving here to do first. Still follow the same solving rules as normal. So just because there's cosines in here doesn't mean we lose all track of solving. We would start by subtracting 9 from both sides and then dividing both sides by 3. So here is where I pause once I get the trig value by itself and say, okay, I've got cosine is what kind of number?
Negative.
Negative.
Negative. So what 2 quadrants are we going to be looking at? Cosine is associated with what?
3 and 4.
Because
Cosine is associated with x, which means cosine is negative in
2 and 3.
2 and 3. Okay.
Oh.
So I'm going to, in my calculator, to get my first answer, type my inverse cosine of negative 2 over 3. My calculator tells me what? About 132. Now, what is the problem with this 132 for my first answer here? Is that my reference angle?
No.
No, that is
No.
this, which is the answer, and that's totally fine, but that's not the reference angle, and right now I can't, I mean, I could use that. How could I use that to find my second answer?
180 minus 132.
You wouldn't do,
Plus 90.
yes, so you could do 180 minus 132 to find the reference angle right here. And then use that reference angle to then find your angle in quadrant 3. So that's kind of a 2-step way. You could also, if you wanted to, rather than thinking reference angles, just looking at my picture here, you could go backwards 132 degrees to get to your angle in quadrant 3.
You
Either
just put negative plus and negative 132.
you can use negative angles for 4th quadrant answers only.
Okay.
They're not considered proper other than that. So I would, if it was me, either subtract from 180 to find the reference angle and then add that reference angle to 180, or I would do 132 subtracted from 360 and make my second answer 228. You're so used to dealing with reference angles that tends to be how I do them automatically. So I would have probably subtracted 180 minus 48, or minus 132, found the reference angle of 48, and then added that to 180 to get 228. But honestly, like having the skills to just figure out where that is, I don't care how you get there. It's just that you do get there, you know? All right, so now how does the chart tie together with this? Well, in questions like 3, we get a cosine value like negative 2/3 that we don't see in our chart. However, when I get a question like 4 and I go and solve question 4, let's see what happens. So 4 has an additional 2 things to it. First, I'm going to start solving for cosine like I would normally. Divide by 4. Now we also have a cosine squared. How do I get rid of a squared on a cosine?
Square root.
Square root. And being careful that when we square root both sides, what do we not forget to put out front?
Plus and minus.
Plus or minus. Now this is how we get more than 2 answers. Okay? Because in this case, we're looking for where is cosine equal to the positive and the negative root 3 over 2, because I can actually simplify the square root of 4. Now, where is this familiar from? that number?
Chart.
The chart. So if kind of the rule of thumb on calculators is if you get a cosine value that is not in our chart, go use your calculator. If we get one that is in our chart, use your chart. Because most of what we're going to be doing is not in degrees, it's going to be in radians. So if you give me a decimal radian when I really need a pi one, I'm going to know that you used your calculator. So it's kind of an obvious thing. For right now, we're in degrees. So my answers are going to be, where is cosine equal to either positive or negative root 3 over 2? So now because cosine is both a positive and a negative, how many answers am I going to have?
4.
4. 1 in every quadrant. Because cosine is positive in quadrant 1 and 2, it's negative in quadrant 3 and 4. Or positive in quadrant 1 and 4. I did the right gestures, but the wrong quadrants. And then negative in quadrant 2 and 3. And if I'm looking at my chart, where's the first place that we see cosine being equal to root 3 over 2? Right here in the first quadrant.
30 degrees.
30 degrees, which means it's going to be the 30-degree reference angle in every quadrant. So one answer is 30. Where am I going to get my other answers?
Negative 30.
And negative 30 could be 1, or I could write that as 330.
Mm-hmm.
Either way, I'll do slash on that one.
You could have 150.
So I could have 150 because I would do 30 degrees before 180. And I could have, what's my other one?
210.
210. Good. So those are my 4 answers where you could make one negative 30 or 330. That's really the only one you could do negative, but I'll have 4 answers total. Okay. Sound pretty decent?
Mm-hmm.
Okay, now really the only other thing is doing this in terms of radians. So while I'm finding our radian page here, let's all take our calculators, switch your mode to radian. Degrees we talk about to get us comfortable with the idea of where are our answers and why do we have more than one. From here on out, everything's going to be in radians. So here's where we're going to start getting more and more comfortable with radians. After this homework, nothing is going to be in degrees at all. Okay, so first off, radians are not going to be nice answers. Remember that, because they're all nasty decimals. They were in terms of pi, but our calculator is not going to do things in terms of pi. The process, however, is the same. You just have to get a little bit more comfortable with the radians in terms of decimals. So let's take question 1 on page 239 in order to get comfortable with that. So question 1, I would start the same way. I'd go ahead and divide both sides by 5. And here's still where I'm going to pause and say I have cosine equaling what kind of number?
A
Negative
negative.
number.
Therefore, my 2 answers are going to be in which 2 quadrants?
2 y 3.
2 and 3. Good. So here's where we would have been comfortable with our calculator's answer in degrees, but we're going to be a little bit uncomfortable with it in radians. Now that I'm in radians, I'm still going to do the inverse cosine of negative 1 over 5. And my calculator is going to tell me 1.772 as an answer. For radians, we're going to go out to 3 decimal places. Okay. Now, here is where we get a little uncomfortable. How do we know whether that's quadrant 2 or 3? Remember our radian quadrant angles. 0, pi over 2, pi, 3 pi over 2, and 2 pi. This helps us because even though they're in terms of pi, I know that pi is approximately what?
3.14.
3.14. So where does 1.772 fall then?
Quadrant 2.
Okay.
And 2.
And now that's important for us to know because just like when we had that 132 degrees going over here, that helps me to know that this 1.772 is not my reference angle, right? Now, what could I do to find my reference angle?
Pi minus.
3.
Mhm. I could
3.14
do
minus
pi minus 1.772. Okay. And for these, if you're using your calculator, I'm going to encourage you to use your answer button. So I'm going to do pi minus my answer. This gives me a reference angle in here of 1.369. What am I then going to do with that reference angle to find my second answer?
Add pi.
Yep, I'm going to do pi plus that reference angle. And again, I'm going to use my answer button. So officially, my two answers are 1.772 and 4.511. If you don't want to use your answer button, then take everything to 4 decimal places until you round off these final answers to 3. Just for the whole significant figures business, if you want to go there. Okay. So this is the only reason why radians is any different. It's because we're uncomfortable with where they're at in terms of the decimals, honestly. Nothing else is any different with this than what we've been doing with the degrees. So for the sake of argument, let's do question 2. I'm going to do a little bit less with these because we've talked about the other ones, and then we'll finish up talking about inverse functions. So on question 2, first off, this is going to sound stupid, but what do I need to do first in question 2? This one gets everyone for some reason.
To move cosecant to the other side and then subtract 7.
Cosecant to the other side, but really this is just a number 3 minus a cosecant, so I'm just going to subtract the 3. For some reason, every year, that one just looks funny to people. It's not a difficult question, it's just how it looks. And then I would divide those guys, right? Now, remember, this is the second one we've done as one of the inverse, or not the inverse functions, the reciprocal functions. We are not as comfortable with cosecant. So what are we going to do with this immediately to make it more comfortable?
Flip.
Change it to sign.
Change it to sign. If cosecant is -4, what sign?
-1
over 4.
-1/4. Good. And here's where we pause and identify our quadrants. Sine is a negative number. Where are my 2 answers going to be?
3 and 4.
Okay, 3 and 4. So I'm going to go ahead and type into my calculator inverse sine of -1/4. My calculator tells me one answer is -0.253. Which of those 2 answers do I currently have?
The 4th quadrant one.
Okay, because we've talked about it a little bit now. Anytime your calculator gives you a negative answer, it's going to be the 4th quadrant one. -0.253. That is also my reference angle, just the positive version of it. So I'm going to transfer 0.253 over there as my reference angle in quadrant 3. And what am I going to do to get my second answer?
Pi plus that.
Pi plus, and then this one I'm not going to use my answer button because my answer was negative. So I'm going to say pi plus 0.25, and I'll go like 268 when I type it in or something just to give myself a couple extra digits so I'm not messing with the rounding. And my second answer from my calculator is 3.394. If you don't like that -0.253, you don't have to keep it. You can always say 2 pi minus 0.253. I'm not sure why you would want to do extra work on that, but you know, totally up to you. So just a couple things about your calculators with this before we do question 4. Your calculators, a general rule of thumb, and some of you may want to write this down, your calculator is never, no matter which trig function you're talking about, going to give you an answer in the 3rd quadrant, ever. It's programmed that if you are doing a sine or cosecant function, it will give you an answer in the 1st and 4th. If it's a cosine or a secant, it will give you an answer in quadrant 1 or 2. 1 if it's positive, 2 if it's negative. If it's tangent, it will give you an answer in quadrant 1 if it's positive, 4 if it's negative. So those are kind of your rules of thumb on that. It helps a little bit to know that for something like question 2 or question 1, when we talked about which cosine value it was. I know my calculator is going to give me an answer out of 1 for cosine or 2. So it's not going to be 3. So it kind of helps me identify which is which. That's just programming stuff in your calculator. We can also use our chart for these, which is kind of where we're going to finish up for today. So for question 4, just like we did on the previous page, if a function is squared, how do we get rid of the squared? Square root both sides.
Root.
So I'm going to square root that. It's going to give me tangent is equal to, what's the square root of 1?
1.
1.
Okay, and we use our plus or minus, which is again how we get more answers. So thinking in terms of radians, tangent's going to be +1, -1, +1, -1. So I'm going to get 4 answers out of this. Think back to your charts again. Where would tangent be 1 for the first time?
Pi over 2.
Pi
Oh,
over
pi over 4.
4. So then
My
thinking
bad.
back through my radians, I've got pi over 4 in the first quadrant. What's going to be the pi over 4 reference angle in the second quadrant? It's
3 pi over 4.
3 pi over 4. And in the third quadrant,
5 pi
5
over
pi
4.
over 4. And in the fourth quadrant,
7.
7 pi
Yeah.
over 4. This may be, for some of us, the place that we come back and finally decide to memorize the radians around the unit circle. This may be the place that it comes into play because it makes life a whole lot easier, honestly. Okay. Let's finish up real quick. What else did I need to talk about on here? Let's practice a little bit more with our charts on these next questions here on page 220 or 230, excuse me. So these are going to be, and I'm not going to make you do these in terms of degrees. This applies to your homework as well. We're just going to stick with radians here. And I do want to point out the notation right there is wrong on the notes. It should say 0 to 2 pi, not including 2 pi. You don't want to include both 0 and 2 pi because that's repeating an answer if you do that. So if I look at a question like number 1, I'm given 2 pieces of information. I want to know what my angle answers are for these 2 pieces of information. If I'm given something like tangent is greater than or equal to 0, that's where I start because what this does is limits the quadrants I'm looking at. So what does it technically mean that tangent is greater than or equal to 0? Tangent is what kind of number?
Positive.
Yep. So all this does is if I'm taking a quadrant system and I'm kind of looking for my answers, if tangent is positive, which quadrants is it eliminating right now?
2 and 4.
2 and 4. So I'm not going to get any answers out of those 2 because tangent has to be positive. That's all this second thing is giving me. The first thing, then I also have to look at where is the cosine equal to that. This narrows it down even further. Someone tell me why.
Because the cosine is negative.
Because the cosine is negative. So because the cosine is negative, we've narrowed ourselves down to which quadrant only?
Third.
Third, because cosine's positive there. So in this case, how many answers am I going to get for this question?
1.
Only
one.
1. Where is cosine? Negative √3 over 2 in quadrant 3. I'm still going to use my chart that only gives me quadrant 1 to start with. So in quadrant 1, cosine is equal to positive √3 over 2 at which radian? Pi over what?
1 over 6.
6.
Pi over 6. That's not my answer because I'm not in quadrant 1, but it is my reference angle. So I'm going to use this pi over 6 as a reference angle in quadrant 3 to figure out what is my answer for this particular question.
7 pi.
7 pi over 6. And for those that are not understanding, remember that 180 is the same as pi. If I'm doing fractions, pi is like 6 pi over 6, and I'm adding 1 pi over 6, which is what gives me the 7 pi over 6. So this is where I was saying, like, we get used to having 2 answers for every question based off of some restrictions that you might be given. You may only have 1. You may have no solutions occasionally based off of how it's written. Sometimes you'll have 4, like with the square root ones. So don't expect 2 answers. If it's what we're going to see as like a typical question, you will usually have more than 1 answer. But It just depends. There's no actual for sure thing on this. Same type of thing with question 2. Sine is 0 and cosine is -1. This one is less restrictions and more just looking at our chart to find values. So we would like to know, where is sine 0 and cosine -1 at the same time? So if I look at my chart, first off, in my chart, do I have a place where sine is 0 and cosine is -1?
Mm-mm.
No, I
No.
don't have one for 0 and -1, but in my chart, I do have 0 and what?
+1.
+1. Where does that happen?
0.
At 0, right here, 0 radians. My sine is 0 and my cosine is +1. So just think about this in terms of our quadrants. If cosine is negative, that indicates where are we on our unit circle or our quadrants.
On the x-axis.
Over here on the left-hand side, cosine
Okay.
is negative all over there, right? So because at 0, sine is 0 and cosine is +1, where is this going to happen where cosine is -1?
180.
180 over here. But in this case, let's start with
180.
which happens to be what?
Oh, so pi over, or just pi.
It's pi. That's it.
Pi over
How
1.
that was like 0 actual math work and all thought process.
Brain power.
I know. If you can use your chart and like what you remember of the unit circle, you're going to go through some of these really quickly. This is another one that someone kind of uses the phrase muscle memory with. The more you practice with these and finding these specific values, the faster and more comfortable you get with this. Again, for those thinking BC calculus, because I know I have a couple of you on here, this is something you need to be able to do in your head. Like not looking at a chart, not looking at a unit circle. And again, I know like distance learning, you're at home, so we have to plan that everything's like notes or open notes. So just if you are thinking, especially BC calculus, you need to be going through this pretty quickly in your head. AB, it's a little bit more typical to use or be able to use a chart and not a unit circle, but if you're not doing either one, it's a little bit less important for you. So just think that way. As we go into this, the rest of the fourth quarter stuff, some of this I realize I'm going to have to understand is open notes and I can't control. So I'm going to try to help out with try to do things this way if you're going to be taking this class next year. I am not going to talk about any more of those notes, but I do want to take a look at page 233, 234 real quick. Just some notation stuff. On this page, you see a lot of inverse sines, inverse tangents, inverse cosines. This does not necessarily mean plug these into your calculator. This just means understand what the notation is saying here. These are the same as solving questions that we've been doing. This is asking the question, where is sine equal to 1/2? Even though it is in the inverse notation, it's still asking that same question. So where is sine equal to 1/2? Using my chart, sine's equal to 1/2
And the angle.
in quadrant 1 at pi over 6. And then I would think in terms of reference angles, sine being positive in quadrant 1 and 2, it would also happen again at what other radian? Five pi over 6. Because we'd be thinking in quadrant 2 using the same reference angle.
Mhm.
Does that make sense or no, what those kind of questions are asking?
Wait, why are we putting it in radians this time instead of degrees?
We are going to typically stick in radians.
For fun.
Introduced in degrees to get you used to where are these and why do we have two answers. But going into calculus, everything's in radians. So we're going to get more and more and more used to radians. And that this is the unit where we do this. Those kind of questions are super easy. Take a look at page 234. This arc sine business, I don't really care about this page too much. But this is the same as this. Arc sine is like an old way of writing inverse sine. So arc cosecant is just inverse cosecant, you know, that kind of thing. Actually, let's all look at number 14 real quick.
Why did they? That's gross.
Why do they do that?
Yeah.
I honestly think it was from a time period before like math type and formulas were super available. And it was easier to be able to type using letter notation because they didn't have all of the software that we have now. It's my guess, but it's kind of antiquated at this point and you won't see it a whole lot, but you do see it occasionally. In fact, one place that I do see it is on the dual credit final. Yay, because we like to be old school there. Though we have no idea how that's going to come at this point.
Oh, yeah.
College is pretty much not going back for the semester, most colleges. So that may be online. We shall see. We will let you know as soon as I know. It's lots of fun. Like I said, 14 real quick, I want to talk about the ones that don't look nice to us. First off, on this one, I would be thinking, okay, this is inverse cosecant, or asking me where is the cosecant equal to root 2. Just like the ones on the previous pages, if it's in terms of a reciprocal, I typically turn it in to the one that I'm more comfortable with. So the reciprocal of cosecant is what?
Sine.
Sine. Now, if I do the reciprocal of root 2, what is that going to be?
1 over root 2.
1 over root 2.
Okay, is this something that we see in our chart?
No.
No, this does not mean immediately go to calculator, okay? Remember how I told you I was never going to make you fix a radical, but it could be helpful to you occasionally? This is
Okay.
one of those cases. Mentally do a quick check. If I multiply by root 2 over root 2 here, do I get something in my chart that I recognize?
You get root 2 over 2.
Yes. Is that something I see in my chart?
Mm-hmm.
Yes. So sine is equal to root 2 over 2 at which radian in quadrant 1?
Pi over 4.
Quadrant 4. Sine is associated with y values, so what other quadrant
3
are we?
pi over 4.
3 pi over 4 in quadrant 2. Yeah? So that one had like a multi-part process just to get that. Sometimes you're going to have to work through a few of those steps to get something accurate with that. Take a look real quick at 19 through 26. These are multi-part questions. Typically with these kind of questions, or let me see. Let's actually go to, these look a little nicer, 236. This is where I threw a bunch of stuff at the notebook and don't do all of it, but actually most of this is not going to be assigned to you. So there's that. I'm just looking at a few things to work through. These are kind of, these are like working backwards problems, working from the inside out. So for example, let's look at 24. These still follow order of operations. So for example, this right here, I would go from the inside of the parentheses and work out. So for example, that is saying, what is the sign at pi over 6? Where can I find that?
Chart?
Your chart. So sine at pi over 6, according to
Oh.
the chart, is what number?
3 pi over north square root of 3 pi over 2.
Root 3 over 2, right? No,
1 over, it's 1/2.
it's 1/2.
1/2.
Okay, so once
Oh,
I get
yes.
that value from my chart, then I work to the outside. Now, notice this is a cosine inverse. So it's asking me the question, where is cosine equal to this? So notice the first one was a regular sine. So it's saying, what is the sine value at this radian? The outside one is an inverse cosine. So it's saying, where is the cosine equal to this? So thinking about cosines, cosine is positive, first and fourth quadrant. To find out where is cosine equal to 1/2, I would look at my chart. Cosine's equal to 1/2 at pi over 3 in the first quadrant. So that is this guy right here, the pi over 3. I'm then going to use the pi over 3 reference angle in quadrant 4. Anyone remember what that is? Pi over 3 backwards from 2.
Oh, it's positive x. Dang.
So thinking pi minus pi over 3.
5 pi over 3.
5 pi over 3. Okay, so these kind of work from the inside out. Would we like to do another one of those?
Mm-hmm. Yes.
Yes. Okay, let's look at 23 real quick. I would work from the inside, cosine at pi over 3. Where do I get that?
1/2.
Okay, my chart,
Okay.
that's 1/2. Then this is an inverse sine, so it's asking me at which angles is sine equal to 1/2. Sine's equal to 1/2 at pi over 6. And thinking about our quadrant system, where else would sine be a positive value?
11 pi over 6?
Over here? Yeah, in quadrant.
Oh, positive.
So sine is positive at pi over 6, and where else?
5 pi over 6.
Pi over 6.
Yes, Nick.
Okay.
You'd be killing it.
Questions, while they're not assigned, they're really, really good for your brain in thinking about this stuff. They make you think both forwards, finding a sine value, and backwards, finding an angle value. So those are like really, I'm not making them part of homework, but these are great extra practice questions. And start on the first page, just finding where is the sine value 1/2, where is the cosine value 1/2, and then work into some of the harder ones like these, multi-part ones, to get yourself used to thinking both forwards and then backwards on these. Homework on this skips around severely, so definitely check my PCA for these questions. And by skipping around, I mean, I don't want you to have to do like 6 pages of homework. So real quick, let me find this. The homework that I have assigned on this is, we're looking at what, 8.6. It's like 5 through 15 odds on this first one on degrees. So just the odds on page 237 and 238, 5 through 15. And then questions 17 through 20 at the bottom, all. The evens 2 through 8 on 239. And then 9 through 12, all. And then 1 through 6 on this page, 241. So I tried to skip around to what I find to be more important, even though it's a little confusing to skip things. But yeah, a lot of it's working backwards. I can post, would we want blank charts to be able to print out again? Or do we have them still?
How it feels.
We
Okay.
got him.
I mean, I think they're still under Unit 6 posted there too on my Canvas. So if anyone needs anything though, let me know. I'm happy to post extra stuff for you, and then we will go from there.